All right, so this is Math 209, Week 2. We are doing Section 6.2. We're factoring. So this is the opposite of multiplying. So think of this as division. So the idea here is to factor. So I'm going to let's kind of put this away for a second, and let's think about multiplying. All right, so when I have like x plus 4 times x minus 3, all right? I've been advocating that I want my students to use the box method, all right? And the idea is this becomes x plus 4, and this becomes x minus 3. And then you multiply. So you get x squared minus 3x, you get positive 4x, you get negative 12. And then you can see that we have some common terms right here. So our answer ends up being x squared plus 1x, because that's this part right here, and then minus 12, because that's this part right here. All right, so that's you start with your two terms, and then you multiply, all right? What today's videos, or this video is all about, is about doing it in reverse. I give you this. You're going to use the box to work backwards and figure out where we started from, all right? So that's the whole point. So if you use the box to multiply, then you're going to love how we do this, using the box to factor, which is kind of like division. So what you're going to do is, because we're going to factor this trinomial, you're going to start with a box. And you're going to start with a 2 by 2. How do you know it's a 2 by 2? Well, you know it's a 2 by 2 because the little exponent is a 2. And since that little exponent is a 2, that means you know it's going to be a 2 by 2 box, all right? And then we're going to put these terms in. Now, we know the first term, x squared, goes there. We know the last term goes here. Now, this 5x, we don't exactly know where that 5x goes. I'm going to write this, by the way, over here. All right, so we don't exactly know where it goes, but I'm going to tell you this first term, the x squared, always goes in the upper left. The third term, that 4 in this case, always goes in the lower right. And now what we're going to do is we're going to use logic. Well, what times what gives you x squared? Well, you only have one choice. It's x times x. That's the only way you can get x squared, x times x, all right? Now, how do you get a 4? Well, you have some choices here. You could do, let's see, you could do 2 times 2, all right? But if we do 2 times 2, and that, sure enough, gives us the 4 right here. But right here, that gives us 2x. And this gives us 2x. And when we add, we get 4x. But we didn't want 4x. We wanted 5x. So my options of 2 times 2 doesn't work. So I'm going to go backwards. And I'm going to try another choice. The other choice is 4 times 1. So let's see if that works. Well, right here, 4 times x is 4x. And right here, 1 times x is 1x. So when I add, this guy is x squared. 4x plus 1x is 5x, and then this guy is 4, and look at this. I got exactly what I wanted. So what's my factor? So we're going to factor it, and so what we get is this red part out here is our factored form. It's x plus 1 times x plus 4. And that's right here, x plus 1, x times 4. So really, basically what we're doing is we said, hey, we started with x squared plus 5x plus 4, and we figured out by, oops, I don't want that parenthesis there. And we've figured out using the box that that is written as, or factored as, x plus 1 times x plus 4. And it's this part right here that you're going to put into my math lab. So now that I kind of did a great detailed explanation, now I'm just going to go faster. So we've got y squared plus 10y plus 16. And I'm going to put that in our box, 2 by 2. And we know that this is y squared, and we know that this is 16. So by process of elimination, we automatically know that that's got to be y times y. And that's the only way you could get y squared. Now, we have some choices over here for 16, and it's just a matter of guess and check. It's like, what times what gives us 16? Well, you have some choices, man. You could say, well, what times what equals 16? Well, you could do 1 times 16, you could do 2 times 8, and you could do 4 times 4. So we have some choices. And so you're going to guess one of these choices and put those numbers here. So I'm going to guess 2 times 8. So I'm going to put my 2 here and my 8 here. Now I had a choice. I could have put, I could have put the 2 down here and the 8 here. I had a choice. They could have been swapped. Sometimes in one configuration, the 8 and the 2 doesn't work, so you have to reverse it, and then suddenly it works. So you got to try all your possibilities, and it really is just a guess and check activity. So let's multiply. So we got y times 8, so that's 8y. Then right here we got 2 times y, so that's 2y. And then if we add those together, y squared is y squared. There is no like term. We can see that 8y plus 2y gives us 10y. And then the 16 is right here. And look at that. That is exactly what we were looking for. So that means our factored expression is y plus 2 times y plus 8. And where did I get that? That's what you're going to put into my math lab. Where did I get it? I got it right here. Y plus 2 and y plus 8. Now this one's going to be a tricky one, but it actually makes it super duper easy. So our trinomial is x squared plus 35x plus 41. So we're going to go over here. We're going to make our box. And we know that x squared is going to go here, and we know that 41 is going to go here. Always, 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 always. All right? Now that means that this is going to be x times x, because that's the only way you can get x squared, is x times x. Now let's think about 41. Well, 41 is prime. The only way you could get 41 is 1 times 41. That's your only choice. So if we put 1 here and 41 here, and we multiply, so you got x times 1, so that gives you 1x. And then you've got 41 times x right here, so that gives you 41x. And then if you combine those and add your like terms and all that sort of stuff, you're going to get x squared plus 42x plus 41. Well, that's not at all what we wanted. So what that means is you're going to have to backtrack, because maybe we need to swap the 41 and the 1. So let's backtrack. All right. And so let's put in, and I kind of accidentally erased this. All right. So we're going to swap it. So I had the 1 here, so let's swap it. And let's put the 1 here and the 41 here, just in case it makes a difference. But when we multiply x times 41, I get 41x. And then down here, I get 1 times x is 1x. And then again, when I simplify, I get x squared plus 42x plus 41. And again, that is not what we were looking for. So what this means is it is impossible for us to factor this trinomial. And what that means is the polynomial is prime. Our trinomial is prime, meaning it cannot be factored and broken up into smaller pieces. Kind of like you could think of the number like 13. 13 is prime because the only way you can factor 13 is 1 times 13. You can't really break it apart. Whereas like 12 can be like 2 times 6 and 3 times 4, all right? So our polynomial is kind of like 13, meaning it can't be broken down further. All right, so let's do another one. So we've got x squared. Now we're just going to practice. X squared plus 12x plus 27. So we're going to go over here. We're going to make our box. It's a 2 by 2 box. We're going to put x squared here. We're going to put 27 here. And we know that the only way you can get x squared is x times x. So now let's think about 27. So we're going to put 27 over here. So 27, we're going to think about 27. Well, 27 can be 1 times 27, 3 times 9, and that's your only combinations that will equal 27. So which combination do we want to try to multiply to get 27? Well, I stick with the numbers that are not extreme. I usually stick with the ones that are the closest to each other. In this case, it's 3 and 9 versus 27 and 1. So let's multiply. I get 3x, I get 9x. So let's check to see if we're right. So you got x squared because that's right here. There is no like terms. These guys are like terms. There's 12x. So I get plus 12x plus 27 because 27 doesn't have any like terms. And look at that. I got exactly what I was aiming for. So what is the factored form? It's x plus 9, because that's this guy right here, x plus 9, times x plus 3, because that's this guy right here, x plus 3. So this is your factored form that you would enter into my math lab. All right, so let's just keep going. And the idea is just over time, the more you do, the better you're going to get at guessing on your first try. But it's really always just a guess. It's just a guess. Mathematicians, pro mathematicians, we're still guessing. We just kind of get good at guessing. So you got y squared goes here, 28 goes here, and the only way to get y squared is to have y times y. So now let's think about that 28. So I'm going to go, let's see, 28. Well, you can have 1 times 28. What is that? What did I do? 1 times, I want that to go away. Go away. All right, so 1 times 28. I've got 2 times 14. And I've got 4 times 7. Those are the only combinations that could be multiplied to get 28. Now, I happen to be looking at, I know it needs to be 11. And I see that 4 and 7 kind of has a combination that equals 11, whereas like 2 and 14, if you subtract, you can get a combination that equals 12. Or if you add, you get a combination that equals 16. But I can see if we have a combination that equals 11. So my first guess is going to be 4 and 7. I could have put the 4 down here instead and the 7 up here. I just guessed. I just put them there. It's just honestly a pure guess. So now let's multiply. Y times 4 is 4y. And then 7 times y is 7y. And now we're going to add up our like terms to see if we're right. So you get y squared plus, and then 4y and 7y, that's 11y. And then the 28 has no like terms. So he just stays there. And look at that. That was exactly what we were aiming for. So our factored form is y plus 7 times y plus 4. And that is your factored form. All right, so now it gets a little trickier because we're now dealing with some negative numbers in there, but it's really the same basic stuff, right? So the only thing is now we're going to throw in some negatives. So it isn't that hard. You'll get it. You will get it. Again, the x squared definitely goes in that first corner, always, always, always. And we know that the 28 always goes in this lower corner. Now, because I see some signs here, I'm going to really be specific, and I'm going to put that positive 28 right there. So now, we know the way to get x squared is x times x. Dang, it's blowing wind. Oh my gosh, it's like a tornado. So that's the way we're going to get x squared, is having our x times x. Now the idea is, how are we going to get our 28? The interesting thing is, we know that these guys right here, when we add them together, we need to get negative 11. All right? So what that means is, we're going to start with just ignoring the signs and say, well, how do you get 28? Well, that's 1 times 28, it's 2 times 14, it's 4 times 7, all right? And ignoring the signs for a second, we see that 4, let's see, can I make it smaller? Yep, there. Okay, we see that 4 and 7 equals 11, all right? So when I multiply to see if we're right, okay, I get x times 4, and that's 4x. And then right here, 7 times x gives us 7x, okay? Now, when I add, I get x squared. But here's the pisser right here. If I add these together, I get positive 11. Positive 11. I didn't want positive 11. I wanted negative 11. So really what that means is I need this guy to be negative and this guy to be negative. Well, if I want these guys to be negative, that means instead of this being a positive 4, it needs to be a negative 4. And instead of this being a positive 7, I need it to be a negative 7. Now, what's really cool about that is negative 7 times negative 4 is still positive 28. So we're cool. It still works. All right? And so I can combine my like terms to make sure we're right. So x squared is x squared. That's right here. Negative 4x plus negative 7x gives me negative 11x. And then we have plus 28. And so there's our like terms. Okay, and so we are done. We got exactly what we wanted. So what is our factored form? Well, it becomes x minus 7 times x minus 4. Because we needed this to be a negative 7. And we needed this to be a minus 4, a negative 4, so it's minus 4. All right, so we're going to do more of the same. So we've got x squared minus 15x plus 56. All right, so our box, 2 by 2. And we know we're always going to put the x squared there, and in this case it's a positive 56, always goes in the lower right-hand corner. So that first term always goes in the upper left, the third term always goes in the lower right. All right, and now we're going to start using logic and guess and check. We know that's got to be x times x, so that's easy. Now let's think about this 56. Now, temporarily, I want you to ignore the signs. Just totally ignore the signs. And let's think about 56. How do you get 56? Well, 56 is, let's see, 1 times 56, it's 2 times 28, It's 4 times 14. It's, let's see, 6 times 9 is 54. So then it's 7 times 8 is 56. So there's all the ways that you can multiply to get 56. So which one of these choices do we want to multiply to get 56? Well, we happen to know that we want the answer to be 15. When we combine these two terms, we want the answer to be 15. So does one of these choices equal have a combination that makes 15? Yeah, this 7 times 8. Because if this is a 7 and this is an 8, we see that, okay, we've got 7x here, we've got 8x here, and that's going to give us 15. But we don't want 15. We want negative 15. So what does that mean? That means we know that this has got to be a negative 7 and this has got to be a negative 7. And so that means this is going to be a negative 7x. This is going to be a negative 8x. So when we combine our like terms, you get x squared. Then you got negative 7x and negative 8x. That gives us negative 15x. And then you have your positive 56 or plus 56. So we ended up with exactly what we were aiming for. So what are our factored forms or factored terms? It's x minus 8 and x minus 7. So this is the same kind of stuff, only they're just choosing different letters now. So it's, let's see, n squared plus 8n minus 65. All right, so our box, we know we're going to have n squared here. We're going to have negative 65 here. And we obviously know that that's got to be n times n. That's the only way you could get n squared. And so now what we've got to do is we've got to figure out what two numbers are going to be multiplied to give us negative 65. Now the trick is, for a while, you ignore the negative. Just ignore it. Let's just think of all the combinations that equal 65. 1 times 65, 5 times, oh gee whiz, what is it? 5 times 13, and that's it. That's the only two combinations that equal 65. So which one of these combinations do we want to try for here and here? Do we want to try 1 and 65? Or do we want to try 5 and 13? And keep in mind, we might have to reverse it as well. Well, since we know that we want these two terms to have a combination, adding and subtracting wise, to equal 8, I see that we should probably try this guy because I see that 13 minus 5 is 8. Okay, so I'm using some logic. So I'm just going to use logic, guess. This is a pure guess. I'm putting the 5 there and the 13 there. And again, ignore the signs temporarily, okay? We're just ignoring the signs. And now we're going to pretend, we're going to multiply. So n times 5, that gives us 5n. And then 13 times n is 13n. All right? So now, when I combine my terms, I get n squared is right here. Now here's the thing. When I combine these terms, am I going to get 8? No, because this is 13, this is 5, and if I add those together, I get 18. So what could I do with these two numbers to get 8? Well, if this guy was a positive and this guy was a negative, that would give me 8. So now I'm going to go back. Well, how do I get a negative 5n? Well, that means this 5 up here must have been, needs to be a negative 5. And then down here, if I need this to be a positive 13n, that means this 13 has to be a positive 13. And sure enough, how did we get the negative 65? Positive 13 times negative 5 gives you negative 65. So things are starting to look good. So what is this positive 13n and the negative 5n? What do they equal? Well, that's equal to positive 8n because there's more positives than negatives. And then you've got the negative 65 left over. So this equals exactly what we wanted it to. So what is our factored form? It's n plus 13 times n minus 5. N plus 13 times n minus 5. So if I were to multiply these two together, I would end up with n squared plus 8n minus 65. All right, and we're going to keep doing this, and we're going to continue using that box. So you got a squared plus 5a minus 45. And we're going to go over here. And we know that a squared goes here, and the negative 45 goes here. Every single time, that automatically means a and a goes right there. And then we're going to think about this 45, but we're going to ignore the sign for a second. We're just going to think about plain old numbers. Well, what do we got? We got 1 times 45. We've got 5 times 9. And that's the only combinations of that equal 45, right? No other combination equals 45. Okay, so what are we going to do? Well, let's put in, I would say, since we want these two terms to equal 5a, let's choose the ones that are closer, not the ones that are further apart from each other. So let's try 5 and 9. Now we have a choice to put the 5 here or the 5 here. And it doesn't make a difference. I mean, your guess is just a guess. So let's put 5 and 9 like that. And we're just guessing. We don't know. And right now, we're also ignoring the negative. Just ignore it. So let's multiply. So what goes here? 5a. What goes down here? 9a. Now we know that our first term works out perfectly, a squared. We want an a squared, we got an a squared, everything's good. And we know that that last term is going to work out just fine eventually. It's going to be minus 45. That's this guy right here, right? It's the middle terms that are kind of problematic. It's these two guys, right? Now, when we look at these two guys, is there any way you can combine them such that you get a 5? No. If they're both negatives, if one is negative and the other is positive or vice versa, or if they're both negative, it's just not going to give us a 5. So what does that tell us? Well, that tells us that our idea, our guess of 5 being where it is and the 9 being where it is, that just means this was a wrong guess. So I got to get rid of the 5 and the 9. And let's reverse it to see if it works. So I'm going to put the 5 down here and the 9 down up there. So let's see if that works. So when I multiply, I get 5a, I get 9a, and nope, there's just no way using these two. So the a squared works, the 45 works, we got that. It's this middle thing. And we see that there's no way we're going to get 5a. At best, we're going to get 4a. And so that tells us that this trinomial is prime. And it took us 3.5 minutes to show that it is prime. Cannot be factored any further. All right, and the last one. So we've got x squared plus 2x minus 24. And we're going to make our little box over here. And we know that the x squared goes up there, and the negative 24 goes down here. And we automatically know that the way to get x squared is to have an x times x. Now we've got some choices for 24, and we're going to ignore the sign, and we're going to think about 24. Well, how can you get 24? Well, 1 times 24, 2 times 12, 3 times 8, 4 times 6. We have a lot of choices. And it's going to be a pure guess as to which one we're going to choose and to see if we're right. But we could do a little bit of logic. We know that we want these two terms to have a combination in some way that equals 2. Can you use 1 and 24 in any way to give us a 2? No, because if you add them or subtract them, there's no way you're going to get a 2. How about 2 and 12? No. If you add them, you get 14. If you subtract them, you get 10. No good. But if we look at the 4 and the 6, well, if you add them, you get 10. That's no good. But if you subtract them, you get a 2. So that means I'm going to choose as my guess. I'm going to choose as my guess 4 and 6. So I'm just going to arbitrarily put the 4 there and the 6 there. That is a guess. We might need to switch the 4 and the 6 to see if it works. So let's multiply to see if we're right. So we've got 4x here, we've got 6x here, and so now when we combine our terms, we've got x squared, because that's what we got, or what we want. But now, if we combine these two terms, do we get 2? No. Technically, if we add them together, we get 10. We don't want 10, we want 2. So how do we get a 2? Well, we make this guy a negative, and we make this guy a positive. And that suddenly makes it so that we now will get the 2x that we're looking for. So backtracking a little bit, if we want a negative 4x, that means this 4 has to be a negative. And that means this positive 6x means this 6 has to be a positive. And sure enough, that's how we're going to get these two terms to equal 2x. And then our last term is minus 24. And so this is exactly what we wanted. So what is our factored terms? Our factored terms are x plus 6 and x minus 4. And that wraps up this video.